mechanism, E2 mechanism. It's a bimolecular mechanism. That's a one-step mechanism involving a transition state. And rate of the reaction is proportional to concentration of alkyl halide. In the case of dehydrohalogenation, it is proportional to concentration of alkyl halide as well as the base. So that is bimolecular. And in this case, the base approaches one of the beta hydrogen. This is alpha and this is beta. And a bond begins to form. So base becomes partial negative, base carries partial negative. Then this bond weakens, a new bond is being formed and CX bond weakens, and this is the transition state. And this transition state, so formation of transition state is the slow state, and the transition state then gets converted into the product, and that is the E2 mechanism. For example, if you consider ethyl bromide, when ethyl bromide a primary alkyl halide, when treated with alcoholic KOH, the product formed is ethene plus HBr. And the mechanism involves the base approaches one of the beta hydrogen and a transition state is formed. So base and this bond weakens, then already there is CC bond and it attains some double bond character, and the CBr bond weakens, and this gets a partial negative charge. So this is the transition state in E2 mechanism, and formation of transition state, that is the slow step. So I can represent the electron movement like this. And for the base to approach this alkyl halide, the preferential direction of approach is if they are in opposite side, that is trans elimination, when H and Br are on opposite side. And then it immediately breaks into the product. Okay. And E2 mechanism is similar to SN2 mechanism, and as it involves a transition state, Usually primary alkyl halides undergo elimination by E2 mechanism. And since it's a one-step mechanism, this E2 mechanism do not show rearrangements. And it is also seen that when deuterated alkyl halides undergo elimination, they undergo elimination at a much slower rate compared to the corresponding alkyl halides. For example, if you treat 2-bromopropane and deuterated bromopropane, it is seen that deuterated bromopropane undergo elimination at a slower rate. And this can be explained based on the fact that as it's a concerted mechanism which involves breakage of CH and CD bonds, CD bond breaking is comparatively slower because its bond energy is greater. And let us see the stereochemistry of E2 reaction. E2 reactions are stereospecific and they proceed with considerable ease when the departing groups are trans than when they are cis. And if the structure permits, E2 reaction yields the trans product, because in that case, the two leaving groups will be as far as possible in the transition state. And when the two eliminating groups must be periplanar, that means they should be in the same plane. We have already seen that in the mechanism. If these two departing groups are as far as possible, then elimination will be more easier. And periplanar means the two departing groups are in the same plane. So in this case, you can see the two departing groups are syn. That means they are in the same direction, whereas in this case, the two departing groups are anti to each other. And in both these cases, they are periplanar, that means in the same plane, but anti-periplanar is more preferred because the departing groups are as far apart as possible. So E2 mechanism, that is stereospecific, and as it is trans elimination. For example, if you consider a case, if you consider a compound having this structure, so consider this enantiomer and the second enantiomer. So consider the two enantiomers, and this structure we can write it like this. So this is the structure of one enantiomer, and the second enantiomer we can write the structure as so. In these cases, what happens is base that approaches the hydrogen atom Then this bond and this bond vacants. The same mechanism here also. Base approaches the hydrogen atom, this pair of electron given and this CCl bond. So in this case, the olefin formed will be having the structure So in this case, the cis isomer is formed, and in this elimination, the product formed is and this is the trans. The trans isomer is formed. That means enantiomer 1 gives the cis isomer and the enantiomer 2 gives the trans isomer. And the starting compound is 1-chloro, 1,2-diphenyl propane. The compound is 1-chloro, 1,2-diphenyl propane, and this compound is optically active. There are 2 enantiomers, and the final product formed is, that is 1,2-diphenyl 1-propane, 1,2-diphenyl 1,2-diphenyl So this is the stereochemistry of E2 mechanism.